That's right.
From
Chameleon Technology.
Chameleon Technology is going to talk about energy. And over to you, Ross.
Thank you. So I think you should have the first slide on. It was on. There we go. It was working.
Dun, dun, dun.
There we go. So I'm Ross Haffenden. I have the great job title of being an IoT Strategy Director for a company called Chameleon Technology, and we're actually based just up the road in Harrogate. And just to set the scene about what we do, we were founded 6 years ago on the smart metering rollout mandate for the government. So many of you in the UK will know that 27 million homes in the UK are being offered smart meters, and smart meters are an IoT device. Actually, smart meters globally take up 36% of IoT traffic currently, so they are a big source of the Internet of Things and data. We make the consumer element of the part that goes in the home, so that you'll see on the TV sometimes the little screen that tells you how much money you're spending on energy, how much you're using. We are currently deploying to 27 million homes. We're over 2.5 million into that at the moment of these devices. But the beautiful thing about these devices is it's mandated. It's a comms device, it's a screen. And if by what is mandated by the government, you can offer what they call a consumer access device, that allows us to get the data in real time out from the smart meter and into the cloud. And from that, because it's real-time data, because it's energy data, there's lots of things that we can do with the resolution of both gas and electricity. So that sort of sets the scene. And I usually start my presentations with a question, and the question is, how many of you today have thought about how much energy you're using to charge your laptops, to charge your phones? And the probability is that none of you have thought about that. And we hear a lot about behavioural change, we hear a lot about people getting involved with energy and wanting to use less energy. But I can tell you, after deploying 2.5 million devices, no one cares about energy and how much energy they're using. They want a system, a platform, to take care of it for them. And that is where we're moving, and that is why IoT, Internet of Things devices are helping. So we should think about energy. Of course we should. I think about energy all the time. Yes, it's my job to think about energy. It is. I like to think about energy because I want to reduce the cost of energy to help the socially vulnerable, to make it inclusive, so we have less fuel poor in the UK and across the globe. Also want to improve the environment for our future generations. So there's ways that we can do that with reducing our energy consumption, moving to a more sustainable energy. So we should think about energy, but we don't. And when we move on, I try to explain well, in other areas of our life, we do think about energy. So why don't we think about about energy that we're using to power all our various devices? And I talk about marathon training, which is, I've just done the London Marathon. So I've been doing this presentation for quite a while now, talking about the build-up, how I've been using all the gadgets, all of the IoT devices, smartwatches, apps, applications, pollution sensors, environmental sensors, to tell me how much energy I should be consuming, how much energy I'm getting from my food. And on the day, yesterday, or the day before, Sunday, making sure I had enough energy to get me round the 26.2 miles of the London Marathon, which I did. Actually, but what those apps didn't tell me was it was going to be 24 degrees, so it made it really, really hard with all the winter training. So in other aspects of our life, we are quite interested in energy. You know, maybe it's for fitness, maybe it is just for, you know, making sure that we're not gaining too much weight, etc. But we do look at energy, but we don't when it's concerned with the lights. And there's a reason for this. Energy at the moment is simple. We go to the switch, we turn it on, the light comes on. We go to the fridge, open the door, the light comes on. We turn our oven on, it comes on. We just expect it to be there. We never go to the socket and go, is there going to be any energy at the other side of that socket? It's always there, so we don't think about it. But that journey is changing. And the reason it's changing, One, it's changing because of smart meters. It's part of the smart grid, but mainly because of renewables. We've got scaling of PV, photovoltaic, solar cells, not going away. We've got electric vehicles scaling very fast. Electric cars, electric vehicles will give us the ability to do peer-to-peer energy trading, will give us the ability to use that car as an energy storage. It'll give us the ability to sell that energy to our next door neighbours or our wider neighbourhood. We're going to have batteries in our homes. We look at that and we think, is that actually going to happen? Well, yes, it is happening. It's happening at a very fast rate. So all of a sudden, we as consumers are going to have to decide, where does our energy come from? Do I take it from the car? Do I take it from my battery? Do I take it from my roof? Do I take it from my neighbour? Do I take it from the grid? We're not going to do that because as consumers, we're not interested. So what we need is a platform. We need a service that can take care of that for us. So plugging Ivy, Chameleon, that's what we're promoting. Ivy is an energy assistant platform. Ivy is based on the IBM cloud. We're one of 7 launch partners with IBM, global launch partners, where we're the very first to use Watson Assistant. And Watson Assistant is a conversational platform that allows you to have conversation maybe with a voice device or an application, a mobile application, or your car, etc., etc. And we've been building this for a year, and we launched it in March at an event in Las Vegas, and it's been very well received. So what I want to show now is an aspirational video. This shows what Ivy is capable of as an aspirational video. And there are other areas where it can help the socially vulnerable. It's all inclusive, but this, just to cover any questions later, this is an aspirational video. So I'll just move on.
Ivy, good morning.
Good morning, Ben. While I was in eco night mode, I was able to save you 98 pence while you were sleeping.
Thanks, Ivy.
Ivy, what's the weather doing?
The weather will be cloudy until 10 a.m, then it will be sunny all afternoon. Expect a high of 10 degrees and a low of 5 degrees. Remember your coat.
Ivy, is the car ready?
Yes, Ben. I've checked your calendar for the day and I've charged your car to 85%. The traffic is slow this morning, so I've allowed an extra 15 minutes for the journey. You need to leave at 7:15 a.m.
Ivy, set the house to Eco Day mode.
Okay, Eco Day mode is set. I will make sure the washing is ready by 6 p.m.
Ivy, could you have the washing ready for 5 p.m, please?
Okay, I've done that. The washing will be ready by 5 p.m.
Ivy, hello?
Your energy provider has requested a car-to-grid energy transfer from 6 p.m. until 7:30 p.m. this evening, making you an extra £1.12. Should I go ahead?
Yes, please. That sounds great, Ivy.
I've scheduled this in for you. Have a good day, Ben.
What's up, Ivy?
Welcome home, Ben. Please connect your car to the charger so we can start saving money. I have changed the house to active day mode and have set the temperature to 20 degrees.
That's great. Thanks, Ivy. Ivy, good night.
Good night, Ben. I have set the house to Eco Night mode and your alarm is set for 6:30 a.m. Today, you have earned a total of £2.58. See you in the morning.
So that was Ivy, and what that video was showing is that there's a lot of things, a lot of complexity going on in the background with very simple scripts. So in this instance, we're talking to the Watson voice conversational assistant. It could be Alexa, it could be Google. Actually, it could be Ivy, and then Ivy can distribute that wherever it chooses to go. It could be a Alexa. And what you're seeing there is you're seeing interrupts. So you're seeing where someone's tried to set the washing machine for 6 o'clock start, and interrupt to say 5 o'clock. And then Ivy does the scheduling within the day to say, I need to finish that piece of washing by 5 o'clock. Doesn't matter when it happens in the day, but I will do it when it's most efficient, when it's most cost effective. Then you've got the battery charging, you've got the car battery charging, you've got the peer-to-peer energy transfer of what's going on. And by simple scripts, good night, good morning, set to day mode. Those simple scripts, that's how we know a consumer will want to interact with the new digitization of energy. They won't want to go, put my battery into this mode, put my car into this charge mode. It's got to be very simple and very effective. So the journey, as I said, is getting more complex. So we're trying to remove that complexity by using various IoT devices. We're looking at weather, for instance. We have 500-meter resolution of weather data. So we can go and we can say when your PV is going to be charging within 2 hours. So not just it's going to be sunny today, it's going to be sunny within this period. Therefore, I'm going to schedule a charge to your car, or I'm going to use an appliance in the home at this point in the day. And it doesn't affect. We can interrogate calendar features, so we can know when you're going to go out, when you're going to come home, and that enables the peer-to-peer charging. It's all very well having peer-to-peer energy transfer, but how do you know that you're not going to want that energy that's in your car? So by using all of these different IoT functions and linking into different devices, and we've heard about flood sensors and things, we can put that into to give warnings about unusual weather patterns, weather events, etc., etc. So Ivy is a new way of engaging with energy. It's never been done before. No one's ever given the ability to have a conversation through a voice assistant, or it could be a phone, it could be your mobile phone, it could be your car. And it's seamless, and so it's natural. And that's one of the beauties of the Watson assistant, the way that it's been built above Alexa, above Google. It's been built as this, not just a command and control device, but it's a device that uses cognitive features, AI features, etc. So it learns as it goes along. It learns if I have a conversation with Ivy in the morning at the dinner table or the kitchen table, and then I go to my car, the same conversation goes with you. So it understands the context of your questions and what you're asking, why are you answering that? And so it steps the whole thing on from the normal command and control. But if you want to use Alexa and you want to use Google, you can through Ivy. And we're not going to go against Amazon and Google for sure. We're just working this big ecosystem. So one of the very important things about Ivy is it understands individual personalized lifestyles. Energy use is about how you use. You may live in the same house to your next door neighbor, 3-bedroom, 4-bedroom, whatever. But actually the way you use energy is different. Different car, different appliances, different amount of children, different amount of pets in the home. They all use different energy. So with the ability of Ivy as a cloud platform and our AI and our machine learning techniques, we can drill right down to individual personalized level. And through the in-home display, we've got temperature, we can see humidity, we can see all of the elements that we've been talking about here, so we can make a home truly smart. We have very good behavioral models around the thermal dynamics of homes, how they should work. So we can tell if the double glazing is out of date or your wall insulation is not correct anymore. So we can push advice through various channels. And it's not just a vision of the future. We're working on a number of trials across the UK. Last week, the week before, a company called Verve did the very first blockchain peer-to-peer energy trade between 2 neighborhoods. So this technology is already happening. Nissan, Renault, Jaguar, all involved in peer-to-peer energy trading through cars. We're working on a number of housing projects across the country where we're introducing Ivy into homes through the smart metering network in order to give behavioural insights, direct insights to the consumer. And very quickly, I'll sum up. So there's other applications for energy data, home security. So we can tell if the gas has been left on, for instance, or we can tell through disaggregation if maybe a device is failing, like a fridge freezer, for instance. We can use our appliance behavioural models in order to see if the power consumption of that one appliance is going up. There are limitations to what we can see with 10-second resolution, but we can see quite a lot. Home appliance monitoring, and then digital healthcare, which is really moves on to sort of the vulnerable, socially vulnerable areas. And I just give a quick feedback of how we're using energy data, real-time energy data in this instance. We're doing work with Liverpool John Moore University, where we're analysing smart metering data and appliance data to see behavioural symptoms. That could be that a light is coming on at 2 o'clock in the morning when it shouldn't be. And that could be an indication that someone living with Alzheimer's maybe have a urinary tract infection, or is actually got a sundowning, which is where you're not sleeping correctly, and that can lead to confusion. And we can then send notifications to a helper, a family member, etc., to give insight to what's actually going inside the home. And what we want is independence, more independence for the people living in the home. So with one thing, I think some people mentioned GDPR. One of the key things with Ivy, and based off of the IBM platform, cloud platform, is the conversations that you have inside your home belong to the homeowner. That's a core element of smart metering. So rather than referrals through Alexa, for instance, 60% of the conversation that you have with Alexa or Google is referred, and it's used for advertising and commercialization. This cloud platform is private, and it's you that decides where you use that data, how you use that data. And that is a big thing when you're talking about what's going on inside your home, especially with national infrastructure and smart metering. So it's been built around that point. So we're very excited about how far-reaching Ivy can be. Number of trials, number of IoT devices. We're working with smart thermostat manufacturers, working with other sensor manufacturers around the globe in order to bring this data into the platform and see what changes, what behavioural changes we can make, what insights we can give, and how we can move Ivy forward. And we've only just got started, basically. The mandate has only started fitting smart meters over the last 3 years. It will be finished by 2020, and then that's when the real fun starts. That's when our homes will really be advanced. So that's me, very quickly, I think, in time. And so, yeah, any questions? I've got question times.
Thanks very much, Ross.
Thank you.
There might be some technical questions about
Sure.
how you connect to the internet, and what you
Please,
do,
yeah.
that sort of thing. Might be some questions about the business model or that sort of thing.
Yep.
But who has got a question? We've got one there. So we start with
Hit me.
Andrew. Just waiting for the microphone. Away you go.
Andrew Robinson again, Foundation of Digital Creativity.
Hi.
It sounds very impressive in that. So some of the energy trading is going to be based on the fact somebody's seen an opportunity. Effectively, some people call it opportunity, some people say greed. It's not. People can sell things backwards and forwards to make money. Data is going to be a similar thing. So how are you going to resist that urge that people are going to have, that you've got lots of valuable data? How are you going to resist the fact that other people are going to want to buy that, and how are you going to compete against other people which might offer a similar platform but sell that data? And also, how open is that data that you store?
So it's a great question, and I would start by saying that it's not our data, it's the homeowner's data. So each silo of data is created around the homeowner. So there'd be very clear onboarding journeys around how that data is used, how you want that data to be used, where you want that data to be distributed. And that journey is very much in its infancy. Our business model at the moment is utilities, energy utilities, a B2B model. And that journey has not been worked out, but Chameleon won't commercialise that data. We won't use that data. The data is personalised to the home, and it's within that silo.
And is that locked even if you get bought out, or as an acquisition?
Absolutely, that's a key, and actually it's regulated. It's government regulated. The government have this data communications company which is called the DCC, and the reason they put that in place was so people couldn't get hold of the data and start telling you when you need to switch, etc. Unless you want that to happen. It's privacy of the data is actually at one of the key elements of the smart meter rollout.
Thank you. Phil, I think you're next up.
Phil Jeffries, freelance technical architect. So does it just work with your smart meter, or can it be connected to other smart meters?
Okay, so
got a few questions. That's
the national infrastructure of smart meters means that they call it SMETS2, and our device will work with any smart meter that is fitted. Yeah.
And so presumably there's some sort of a hub which allows you to then connect it to different smart meters over different protocols and so on.
So the architecture is gas meter, electricity meter. Bolted to that is a comms hub.
Right.
This hub has a GPRS that goes back to the DCC,
Yeah.
and then it has a Zigbee protocol that comes to the in-home display.
Got you.
Within the in-home display, if the utility chooses to install that device, there's a device called a consumer access device, which could be a Wi-Fi, could be a 2D module,
Yeah.
and then that gets it out to the cloud.
Got you. Just a couple more. Any plans to add
One
water?
more. Yeah.
Sorry?
Any plans to measure water as well?
Smart metering of water is quite a low priority because of the cost. There's not much, but it comes up from time to time. But at the moment, there's no priority,
okay.
And it's difficult because the water meter is not in the home, so power is difficult.
Okay, I better let someone else.
Okay, thanks, Phil. Who was next? Okay, very good.
Excellent, good.
Right, the same question. We might go back to Phil with his other questions, if that's... Yeah. Phil, what was your other question?
So you talked about the measurement of electricity and gas. What about, so how are you actually actuating devices in the home? What about that side of it, the input back into the system?
Yeah, so in the case of our partnership with Honeywell, so we would we have API calls through our cloud platform. So we get the data, so decide what we're going to do with the data, and then we go do an API call out to Honeywell. And
just Honeywell, or is it
well, wherever there's an open API, we're allowed. There are some smart thermostat manufacturers that won't let you interrogate their own data because they want to commercialize the data.
Can you write your own API calls?
Yes. Yeah. So we use MQTT
Yeah.
on our API. We have a standard API document out from our CAD that gives anybody the ability to say, I want to do something with this CAD. Because we don't just point it at Ivy, we can point it at anyone's cloud service.
Last question. So I think you mentioned the resolution was 10 seconds.
For electricity, 30 minutes for gas.
Right. Okay.
And that's a government regulation.
Great. Thanks for that.
Thank you.
Okay, I think we've got time for one more question. Got one. Oh, Kerry. Kerry, and then this one.
Kerry Batchelder. Just wondering about commercial applications. Are you thinking of that?
Yeah, so there's smart meters are going into non-domestic small businesses, and we have various projects with one example would be a pub chain. Maybe 4 or 5 pubs where we can look at summary data, individual data, and give insight to a manager, etc. So yeah, but we won't do large industrial because that's taken by advanced meter infrastructure, not SMETS, domestic meters.
Thank you.
Alistair Morton, Extract Science. Do you envisage a monitoring device on every appliance? At the moment, you're just reading the main kind of input, aren't you? But do you see a day where every appliance is going to have some kind of smart capability?
That's going to happen. I don't know the benefit to the consumer of every device being connected.
It's just that you mentioned at 2 a.m. the light switched on. How would you have known it was a light if you're just reading the main feed?
Well, that's a great question. So through Through our behavioural models, we have quite a nice AI-based machine learning algorithm which can self-learn and self-teach itself about, well, I know that's a toaster, and I know that's a kettle, and I know that's a refrigerator, and I know that's a light. So and then it does a probability just in simple AI terms. 80% is truth in case, and that's how we do it.
What's the resolution of the reading that it can
Well,
take?
it's a 10-second read.
No, in terms of wattage or amps.
I
What's the
don't
minimum?
know the answer
Okay.
to that. Sorry, yeah, no.
Thank you.
Okay. If we've got no more questions, I think we should thank Ross in the usual way.
Thank you. Thank you.
If you share those slides with us, we'll share them with them. Yeah, fantastic. And then if you want to follow up with Ross, either do it. I think I've just found him on Twitter.
We're looking for trials, looking for devices, looking for things to get connected to see how we can better improve consumers. So everything's on the table.
Fantastic.
Thank you.
Thanks very much. I'll grab that. So Andrew, you're next up. No problem. I'll do this. So thank you. What? Yeah. Very good. No, thanks very much for that. We'll see. Andrew, if you just put that in your pocket, I'll click you on. There we go. Okay, so I'm really looking forward to this. So Andrew Robinson, you tell us a little about what you do and on the things network stuff as well.
Yeah, right. So yes, thanks for the intro. So I'm Dr. Andrew Robinson. Colleague our side was hoping to be here, but she's actually delivering a workshop, so it's not her in the picture, that's not Claire. So we are co-founders of the Foundation for Digital Creativity, and really the foundation aims to make the world a better place by using digital, and that be either through looking at opportunities for individuals to further their skills, or just bring together technological improvements. So one of the things, we have various programs, and one of the programs is the Internet of Curious Things. That's one of the things we deliver. It's really about bringing the Internet of Things to everyone. So I mentioned, it's about making the world a better place. So look at some of the whys of why we're doing it. We want to make people feel empowered, and we want to make the Internet of Things accessible. So it was mentioned earlier, Steve from Bradford mentioned that sometimes there isn't a thing that you can just buy. That IoT is only going to cater for where there's volume. It's likely that there's going to be IoT scenarios where there isn't an off-the-shelf widget that you can just buy. So really people need to know how to even make their own or even prototype it, then they can sort of do a proof of concept. We've also, with Facebook was mentioned, there's questions of data ownership and privacy. If you've got people with devices, Amazon, Alexa and all that, just collecting data about things, then do we want someone at a third party collecting data about everything? Or if you've built your own solution and you're hosting it yourself, then that way you can look after the data and you can really control that. It's about furthering skills, so the individuals that get involved in the program become more employable. They might have an idea about IoT, which they then can turn into some commercialized product, which they manufacture. And then finally, I think, which is most important, it's fun. So this is an example of a workshop we did I was going to say in Leeds, but we're in Leeds. I forget where I am some of the time. Basically, the foundation runs from Manchester. I'm on that side of the Pennines, and then Claire is on this side of the Pennines, so we tend to do most of the north. This is part of Ada Day to celebrate Ada Lovelace, and I think they're making some visualization of data, which I'll get on to talking about later. So I'll just try unplugging it and plugging it back in again. Try. Right, so the computer's seeing a monitor and the monitor's appearing and then disappearing, but it's just trying to persuade the thing to actually fix rather than oscillate. Right, it's not stable. Just have you got that? So I'm trying to continue without some of the slides for some of it. So we talk about really our motivation, or some of the workshops we do is sort of related to Hertzberg theory. So anybody who's management consultant, see whether there's any management sort of people here. Hertzberg theory, anybody know about that? So that was basically around the time of Maslow, and Maslow with his hierarchy of needs. Well, Hertzberg basically said that he was talking about motivation of staff, I think during sort of post-war time, and said that there's two aspects of motivation staff. There's the encouraging factors and there's hygiene factors. And if you don't have a hygiene factor, basically, then forget whatever you offer workers, they're just not going to do any work for you. So we see that as very much similar to trying to get people interested in Internet of Things. So there's two options. There's almost the pull and the push, that you've got to find the attraction. So the work that we do tries to find interesting things that will excite youngsters, or people doing our workshops. This is really distracting because my slides appear and disappear as well. And so I'd like to go to slides if we can by the end of it. I'm running out of ad lib, really. So we try to encourage people to do it because it's something which is interested in them. Just because we're an engineer and we might be interested in the actual technology and the nuts and bolts of Internet of Things, that's not really going to interest people. They've got their own interests. They might be interested in birds, or they might be interested in sun cream, or just see whether my laptop actually will ever work again after the plugs back in.
On off.
Is it worth trying the other dongle?
You connect directly to the
All right.
TV.
Is it all? Has it?
This bit isn't. I'm a bit concerned if screen keeps. Is it on? This is what happens when you don't let people use the map.
So, I was saying that we're finding things which are of interest to the people doing the workshops. So that's one set of factors, and the other aspect is we want to remove barriers, because we've all had experiences when we've used technology and it hasn't quite gone to plan. So yes, thank you for the demo of technology not quite going to plan. So really, it's about two things with IoT. It's one, finding hooks, which will get people interested in what they want to make. It's also two, about removing barriers, and that's what we tend to do. So this is an example of, from that workshop, we set people a challenge of trying to make a world a better place through IoT inventions. And what they'd done, they'd made this smart bottle of sun cream. So you've got a device here with an ultraviolet sensor on, and if the UV levels are above a certain amount, then the sun cream bottle flashes to say that you need to apply more. And then with connectivity, that can then get uploaded, so you can then get the distributed thing and a recording of how much sun you've been exposed to. I don't really see why that couldn't be commercialised as a product, and that came from a group of Year 11 girls. So where did it come from? Well, I was talking about removing barriers. So going back 5 years, I did some workshops to try and get people more interested in coding and making things. So I came up with this as a response to, we'd done some work with Raspberry Pi, but Raspberry Pi was a bit difficult to get started. This, all you needed was a web browser, and then you just plug it in and you can download code and then you can wear it. And as you can see, this was at the Commonwealth Games with the BBC. They were very interested and did some interesting demos. Whether or not you've seen devices like that with the BBC as a follow-up, microbit, is another matter. But we did a bit of work with the BBC, and they branded it microbit. So that's the starting point. So it's all very similar sort of thing, except we've taken the initial concept that we showed them and we've put more Internet of Things on it. So talking about what happens with the workshops. So you typically take a code bug and then you just plug on these various devices which give it various capabilities. So this has got temperature, pressure, humidity, UV, visible light, colour, proximity if you've got things near it. There's accelerometer data, so you can find out which way up it is or whether it's been attached to things. So it's all about breaking it down into these nice, easy building blocks. The hardware is just a matter of plugging the various bits together, and then the software is also these simple building blocks. What it's been used for is over in Hull. So we've talked about the Things North a lot, and so Things North is a collection of things Manchester, things Leeds, things York, things Hull, things Bradford, things Oldham, things Liverpool. There's various communities which have got together and created their own things networks. So one of the things that I did was I'd heard about the LoRaWAN from Julian at Things Manchester, wanted to create it with Things Oldham, which is where I'm based, where we've got offices. Spoke to the council to see whether they wanted to back it, and they said, well, that's very interesting. So we gave them a use case and said you can send temperature data over it, and said basically think of it as if it's a text message, because that's how we explain it to the children, that think of it as if you can put it in a text message and send it, then you can do it with LoRaWAN, except you don't have to pay for a SIM card subscription. So then their next question was, well, can you send humidity data as well? And we sort of said, well, in our head, that's all the same, that if you can convert something into digital data, then you can send it. That didn't quite manage to communicate properly with Oldham Council. So we ended up getting funded to do a project in Hull, which wasn't very convenient for me, but it meant a lot of travelling. But that's why I'm the initiator of Things Hull. And that, I think we've seen about 25,000 packets sent in the last 6 months or so. So one of the things that they did is Hull has got Project Blythe, which sees young primary school children build their own electric racing car. And we were talking about how you could make that better. The race circuit is in Hull. And so they've put in like accelerometer, temperature to measure the motor, thermometer to measure the motor temperature, acceleration, braking, that sort of thing. And they've managed to use this thing to develop their own car telemetry by just plugging the various bits together. Another thing, we work with Siemens. Siemens have got a commercial application, which I can't talk about, but some of the things that we've got, basically the technology is because my background is in engineering, I massively over-engineered that, and so it's industrial use, so we've got some industrial partners using the same thing as well, which also shows that really, if you can teach people how to use these things, there's nothing to stop them taking it on and commercialise it into products. Then the current thing that we're talking about is air quality. So I've got some air quality sensors as well that we've got. This is over in Eindhoven, where we did a workshop and we attached them to kites. So one of the things, somebody talked about sticking air quality things on drones. The problem with doing that is you've got fans which effectively blow it past the sensors, so that changes things slightly. You also end up sensing a different, because air quality is very much related to height, so you do sense different information that way, but it's a good indication. Now, as the output of that data, then you can display it on graphs. It wouldn't have occurred to me to put ducks on the top of my bar charts, but so I always thought bar charts were a bit boring really, but I will put ducks and things like that on them. But one of the things that we do with the workshops to try and make it interesting is we've got these lanterns, so these are connected to the cloud as well through the device, and then the air quality information can then get displayed with the lanterns, and you can then communicate it. And sort of we're talking about the visualizing the data for energy usage, that it's all about how you present it to get people engaged. More data-driven outcomes. We've got some clothing that somebody made there, and then this is Sam Aaron, who wrote Sonic Pi. He took our data in and made some music and event with it. So first secret bit, top secret. This is coming on to our next project, which I'd like sort of help or suggestions about. I don't know if you can read this. This is a top secret memo about the backbone link of radio standby and basically the idea is it's providing more ways that you can get information back. So that actually, this is a project which was top secret in 1956, which was called the Backbone Project. And the idea was the government were very keen to have some redundancy, so have some direct radio links. So they're not dependent on, at that time, the GPO, now BT's underground cables, and they've proposed a whole network of towers. And basically, I got this idea because, as I mentioned, my side of the foundation is based in Manchester. So I spent a lot of time driving over the M62, and I don't know if anybody recognises that. Anybody know where it is? That's on the top of Windy Hill, so just near the highest motorway point in the UK. And I wondered what that was for and sort of started looking into it. And there's another one that you can see from there. This is Heaton Park. And then there's that one which is in North Leeds, which you'll probably know better, which is the highest point in Leeds. And so it turns out that those Chiltern Towers, as they're called, became an extension of the Backbone Project. And I then started playing around, and I thought, well, I wonder what happens if we plot them on a map. And so I plotted them on a map, and also you can see here, there's elevation profile. So 450 metres on the left, you've got Windy Hill here, and you've got the height of that tower over in North Leeds, and they must have complete line of sight because there's no hills in the middle. And then I did a bit of maths as well and worked out what the curvature of the Earth was and what the heights were, and then you realise that actually you've got line of sight between those points. And then I thought, well, what happens if you go the other way? So if you plot the information the other way, so looking at from that hill, looking out, you can see that basically there's between there and the sea, there's nothing. And because it's so high and that's so low, again, looking at the curvature of the Earth, you can actually get line of sight to the bay. So the next thought is, well, if you've got line of sight, you've got these radio links that we've got kids using to collect data, can we have a battle of the city's air quality and also get them to build the radio links between them? Just because it's looking all the time that we do stuff, it's looking for things which engage people, which are things which are a bit more unusual rather than just, oh, you know, we've just learnt to program in Python and we've just displayed a picture on the screen, something like that. So hopefully, I'm looking for people who are interested in joining the vision, and you can help us. So either if you've, we'll do IoT workshops, and we do those for anyone. We'll do them for young people, or we also do them for companies. If you've got some innovation you want to sort of try and get your staff thinking about IoT, then it's the best way of actually getting them to try and build something and play with things, understand how this stuff works. Just do a level that they've got an understanding of it. We're not saying that you're going to replace an engineering team. We're just going to say, you know, you'll have a high-level overview. And then also, if you want to get involved in this, you know, communicating between one side of the country to another, then we'd be very interested to hear from you. Particularly if you've got data sims as our backup, then we could do it just in case the line of sight doesn't work. So I'm at _codebug. The foundation is found DigiCreate. Sign up for the mailing list. There's more top secret stuff, but I believe that this is going to be streamed, so I can't talk about that online. You could probably talk to me about it later, but just to say watch Kickstarter over the next month or so, and it's very interesting. And any questions? I think.
So thanks very much. Inspiring talk. Really good thing to finish on, and I'm sure everyone wants to join in with that amazing project. But any questions for Andrew? We've got one here. Any other questions? So we've got one question at the moment. If you just wait for the mic, and then we'll... Okay. Oh, we've got another one here. Yeah.
Matt Wallace from Mockingbird Consulting. Are the circuit boards that you're putting into the industrial kits the same shape, the little code bugs, as the ones that you give to the school kids?
They can be if they want, but we've also got a boring one if you want to be boring. So
you wanted it to be the same shape, didn't you?
Absolutely.
That would be amazing.
I love the idea of, you know.
Nothing to stop you, go to Farnell. Sorry, Arrow. Just realised that number of times Farnell has been mentioned today, and you've got Arrow in the room. But yeah, go to Farnell, whatever, buy it, and then you can buy any shape you want.
Cool. Question here. Yeah.
Hi, this is Luca Cinti from IoT Tribe. The question is how schools and colleges in general are receptive to IoT?
So I think it crosses over some of the other aspects. What Steve was talking about, it's getting buy-in and getting people to understand what is it that it can do and what are the benefits. So that's partly the challenge, and that's really why we do some of this what appears a bit of trivial stuff, because that's the hook. It's getting people in. One of the things that I've done is a bird box that tweets when birds fly in and out. So then you can have the discussion, and then people say, well, actually, I'm interested in badges. Can I modify it to work with badges? Or it's finding the right hook, or saying, like there's something we've got for monitoring windsurfing. So if people are interested in windsurfing, I can make windsurfing better by collecting the data. So it's just finding that hook and making it accessible, and that's what we do as a foundation. Air quality is something else that we're doing work on at the moment, and that seems to have a lot of relevance because people have heard about air quality, they want to know about it. We don't get the same buy-in from some of the local authorities because we've been told we're not allowed to publish the data that we collect because they know what the outcome will be. But that makes us want to do it even more because that's really about getting the local communities to own that data, and they can detect that the air quality isn't up for it, so they can then lobby the MPs and do something about it. So it's how it fits in a wider context.
Yeah, fantastic, thanks.
Okay, any more questions? Steve at the back. And just to share, when we worked with DFE on Department for Transport and DFE talking about a hackathon, we were told not to look at air quality sensors in any way. So of course we looked at air quality sensors. And there's a massive, I think there's an open project that I think we should put together about what air quality sensors work, which ones don't, what does it mean. Let's stop getting sold stuff that's just a temperature sensor and being rehashed as an air quality sensor a lot. Let's not get, an air quality sensor is not a temperature and humidity sensor. And we need to hammer that home. Anyway, I'll stop bleating on about that. Steve.
Your code bug, and then you've got the things that clip into the side. Where can you buy those? I've got an 8-year-old daughter who'd love it.
Sorry?
I've got an 8-year-old daughter who'd love it.
So Kickstarter would be a good thing to look at next week for some interesting new things, maybe.
But why is that?
Why is that? I just randomly check Kickstarter or sign up on the mailing list. That's probably a good idea to find out about new, interesting stuff, things which I might not have talked about. But also on the air quality sensing, there's also the initial, we've been looking at that for a long time. There's some sensors and basically they tell you whether or not you've died, because if the air quality gets that bad, the detection threshold is either fine, good, or actually the limit that is you've probably died 3 weeks ago with that quality of air quality. So it is good to try and get some good quality, reliable,
And we can't do it on our own, so if we do it collectively, we'll probably get to a better answer quicker, and whoever is selling the best, we can crowdsource a review of that would be a very good thing. Excellent. Any more questions? Steve's got another one? A point?
The air quality, Newcastle University with Sense My Street.
Oh, yeah.
Just a reminder if we're looking at something.
We're trying to get working with those guys, and it was Julie who was supposed to be forwarding details on, and he never did. I can criticise him because he's not in the room now.
Oh, Phil James.
Phil James, right.
Okay, thanks very much, Andrew. Another round of applause, I think. It's inspirational. And if we can get the across the Pennines things connection would be amazing. So next up is Brian Ablett. Brian, if you just introduce yourself. Yeah, I'll get that up. Stuart, just turn A2 up for us. Yep, that's fine. Thank you. Brian, do you want a... Choose your weapon. Do you want a microphone or a clip-on?
Clip-on.
Okay, right. So you clip yourself on, put that in your pocket.
Switched on.
You can find out. Yep, just tap it. Yep, go off. If you introduce yourself, I'll get you on here.
My first slide introduces me.
Okay. Okay, so backs and forwards, and you're off.
Hello, good afternoon. Good afternoon. Those of you here this morning, thank you for staying. It's always a surprise to me when I'm on in the afternoons. I am Brian Ablett, and I'm going to talk about, as it says there, dumb buildings to smarter buildings in some unknown time period. I'm not sure from Paul, but he'll tell me. That says underneath in grey who I am, or is it these days who I was. Chartered surveyor, formerly a registered valuer, which is sort of key, difficult, and a chartered environmentalist. And I took the opportunity to stop being those things because I wanted to go and do something else. There was nothing on my birth certificate to say you've got to do that for the whole of your life and then you sort of die. So I thought I'd do that and see where it took me. So there we are. I'm one of the very few chartered surveyors working in the field of smart cities. Before I stopped paying my fees, because it's a fortune, but my employer used to pay them, I worked out that there were fewer than 6 people in the whole of the UK with my qualification working in the field. So it was quite unusual to have somebody who was interested in the built environment working on city policy, which seemed to me quite strange. So anyway, I thoroughly enjoyed it, and I still do. My career, though, was wholly in the public sector, and that meant that I worked on the client side, and that gave me some curious insights, because I would receive visits from some very good companies, some of whom are in the room today, excellent companies, but they used to tell me what it is I wanted. In other words, is this good for you? I think it is. Would you sign here, here, and write this check? And the answer is, well, no, because you've never asked me what I wanted. And I thought, this is the opportunity I've got in my life to try and develop that line of thinking. Because if I've been the client, and there are people here from Leeds and Bradford and what have you, that's the side of the table I sat on. And I thought, well, if you can't get what you want, there's only one thing to do, and that's to stop complaining about it and blooming well do something about it. So this is really about that. And that last line, in case I throw some of you, I'm aware of the fact, because I've done enough psychometric testing in my life, that I am in fact a lateral thinker and a reflector. So that's just how I am, and I'm guessing most of you are not. Just stick with it, you know, we're going to get there in the end. So this is the journey of my presentation. And we're going to swill around in sort of quite a lateral thinking type way around the top. And if you're not a lateral thinker, just wait for the pointy bit at the bottom, which is where a lot of you are going to find it easier. So I'm going to have some broad ideas, then we're going to have a think about buildings, then we're going to think about sensors. But at the end, I'm quite clear about this is what I want from you, which is why I'm here today. So it's going to be a two-way thing. One of the things that struck me is that, especially in the public sector, but I think elsewhere, that we suffer from a loss of what I call corporate memory. We know what we're doing now, maybe. We might have an idea of what we're going to be doing, and those who work for large organisations, that's called your job description, which doesn't actually mean anything either. But you've no idea what the organisation did, let alone what other people have done to solve problems. And this is really difficult. So when I responded to Paul's shout out for, does anybody want to speak? I thought, well, I'll have a crack at this. Well, one of the things that struck me is, Paul said, got any pictures of sensors? I thought, what was the very first sensor? Do we know? And I thought, I'll look at this because I'm a lateral thinker. And I reckon this is the first one. I think this is version 1.0. Now, this is very much to be found. It's on the Isle of Orkney. I think this is the first sensor. It's at least 5,000 years old, at least. Now, other work by archaeologists reckons this might be short by at least 1,000 years. It's quite old. We can say with confidence it's quite old. And it's one of 2,000 to 3,000 in the UK. And they are distributed across the UK and indeed on the island of Ireland. And that's a large number. And this is a technology that we have wholly forgotten about. We don't even really know what these were for. But we do know that without exception, they look towards the night sky. Now, this is the first one. And after this, there were guys just like you. There were peripatetic henge builders. They went out to get these sensors built, which is sort of what we're talking about today. So I think this is quite close to things. And what you have to look at with that is just how clever they were, because they've sorted out the engineering there and the mathematics. This uses the entire landscape. It's not just a little bit in the foreground, which is, by the way, well over 100 meters in diameter. It uses the complete landscape, including the hills at the back, to give it accuracy. So this is absolutely fantastic beyond clever. And I think we should start thinking about this. We're quite good at this as a species, and it certainly isn't new. And it delivered data in great quantities. It still does. They weren't to know when they built it, however, that it lasted so long that the Earth has changed in its orbit in relation to the night sky. I don't think we can blame them for that. I think that's quite something. But why put it up here? Well, one of the problems I face is that buildings have a very long life. How old is this place, Paul? Oh, you're daydreaming. Well, it's 100 years old? Anyway, and it's not the case that you can get sensors that align to the buildings. So when I worked for a while at Leeds, and the question was, what should we rebuild? They pulled down a bunch of clapped out council housing, and it wasn't the oldest stuff. And the director basically ran workshops which was along the lines of what is a house, which was a very perceptive thing to do. And I thought brightly, well, Brian, you introduced smart city thinking to Leeds Council. It must have lots of sensors in. And I thought, well, no, because the life of the house is 120 years, if you get it right this time. How many sensors are going to be useful over the life of the asset? And the answer is, well, none of the ones that I've seen. They won't last 5 years, a lot of these. So I think we have to start wondering whether what is required in the built environment is actually available. It's certainly, I think, necessary. And I think we have a problem with that. And I don't think people are thinking deeply enough about this. So the answer, in case you're wondering, was to actually propose a house that stepped over the need for sensors, and that provided people didn't interfere with it, it would run itself and provide very comfortable living conditions without the need for supplementary heating, without the need for gas boilers or what have you. And that's what they've done. So as long as they haven't made a bog up of the design of the procurement or the construction, it'll work. But there is an outstanding firm of housing developers in Leeds called C2, who Paul knows and has worked with, who are doing this as housing for sale. They've done schemes in Sheffield and are on site in Leeds. It does work. It works everywhere. So there's no reason why it shouldn't work here. But I do accept that you probably want something that's a bit more current. So let's just jump forward a few thousand years and have a look at this fellow. Has anybody been here? Ah, excellent people, then you know what this is. This then is one of the principal nodes on the world's first internet, more as we understand it today. And it worked really well. So it reduced the time for sending messages from 6 to 12 weeks, steam or sail, choice is yours, to 6 hours. Now that, I reckon, is pretty good in terms of disruption. And it's really fantastic. And when you look at it, I know these aren't good, but there you are. But this shows the network of submarine cables. So down in the left-hand picture there, they all came into Cornwall. And in the blue one, most of them went trotting up to London, apart from a red one which went off, God knows where, to North America, I think. And the one at the bottom there, the snaky red line, shows how submarine cables went completely around the globe. So you've got a complete system. So I think in the first thing you had a very good example of sensors being interconnected. They were all, after all, working to the night sky. They had solved a problem that you have in computing about having everything working to the same time moment. Whereas this one, I think, is far more about it being a network, but rather lacking in sensors. But what could you do with it? Well, it was good enough to run empires on, whatever you might think about them today looking backwards. But also, it was good enough to support this. So this is really important to today. This was a car race in 1907. 1907, Peking to Paris. Cars that looked like that had only been around for 20 years, which isn't very long. So within 20 years, someone had the aspiration to throw down a challenge to race in cars from Peking to Paris. And the challenge was issued in January, and the race started the same year in June. So you had to organise it in 6 months. Now that's pretty cool. So how are you going to do that? So the telegraph system had to work pretty well to do that. I think we have to understand, just because we've forgotten about technology, other people were masters of these things and could really make them work well. So in 6 months, you had to set up a route because there aren't any roads. Racing, no road problem. Then you've got to set up your logistics, but there are no roads. And there's no delivery companies because they haven't been invented yet. Then you've got to set up fuel dumps because there's no roads, there's no cars, there's nothing. So they had to organise the fuel dumps and they had to get themselves out there in 6 months. I mean, it's incredible, really, what could be done. So this then was more important than the first moon landing. Now, when we go on to what I'm doing now, this is then what I call OptiSuite. And this brings things together to try and understand how buildings are being used. And it fits around what people want. Rather than being told what I can have, it's whatever you want. And whatever you want isn't constant across the estate. If you've got a large estate, it's different. And the first attempt I had at doing this was at Leeds. And I wanted to use the corporate network as a single sensor. And it worked all right after a fashion. You can still look it up. It's published as open data, and there's where you can find it. But there were things that I didn't know. It gave us too much data and too little. So I couldn't see what was happening. And I didn't realise that Leeds is unusual in having a well-built network. It's not unique, but it's certainly not common. And in the end, it doesn't tell you enough about what's happening. Critically, it also gave me insufficient data. So this then is what I did. I left Leeds and I chose the Building Research Establishment. It was previously the government's laboratory. It's privatised now into a charitable trust because nobody's going to believe me if I rock up. And we found that the BRE hadn't got the skills in-house to do what was required. We now have an Internet of Things partner, and it is very successful in what it does. And we ran a pilot under contract with a major public body because that was their target to start with. And here's an image then of installation day with this, and there's the little white boxes, which are sensors. Batteries in case there wasn't mains power available, and there's the laptop showing the things coming online as they were built up. And this is the sort of reports that it generates. Now, you're not interested. This is a snapshot. The point being that the yellow lines show that the sun is shining, and then the dark lines underneath shows that not only is the sun shining, but all the lights are blazing away inside the same room. So, I mean, what could possibly go wrong with that sort of approach? So there is a need, before I get to that, and that's the last slide, I'm thinking about how to bring artificial intelligence into this. Not much talk about that this morning. The biggest problem is not the technology. I must underline that. It is people who fear the technology. They don't understand it, though they've probably risen to the top. It's not only cream that rises to the top, is it? And they are blockers. They are absolutely stopping things happening, and they're stopping it happening now. So that's your learning point for today as a non-technologist. And I think in the UK, from my stint working in Holland, I'd say we're late adopters in technology as well. And I think we ought to be impatient about it. This is what I need from you. This is the last slide. I need better sensors that are secure and ethical, by which I mean there are no surprises for the staff. They are not there as victims. Do look up Yahoo News. You find the Daily Telegraph journalists walked out when they found those similar sensors stuck on their desk. They went on strike until they were removed. People don't like the feeling of being watched. You must take them with you. The study had prior consultations with the trade unions, for example, who were completely reassured to the point they couldn't care less, which is a great outcome. The sensors are either too expensive or they're a domestic retail product. They're not really what I need. Just because somebody can make them work doesn't mean that that gives you the degree of reliability that you want at the price that you want. And I need someone with the ability to undertake rapid prototyping, because if I get a requirement that comes in and it's not covered by something I can go and buy, where do I go? So I need that, and it's hard to come by, and it needs to be supported. It has to have the appropriate documentation to go with it, because if the service being offered is always on and the sensors fail, then it's not always on. So that's what I need for you. So if anybody can cope with that, and the fact that I might come and say I want 20, 200 or 2,000, and I need them by Monday, or possibly Monday week if it's 2,000, then that's the sort of response that I need in terms of manufacturing capability. So there we are. That's the book, in case you wondered about it. It's a big book to send by telegraph. Thank you very much.
Okay. Any questions?
Excellent. Oh,
We've got a question from Andrew at the back. Just wait for the microphone.
Just in terms of, you said you need 2,000 by next week or whatever. Just at the moment, I don't know whether you're aware, basically there's a global shortage of various components. So to actually get something manufactured, if you go to the component manufacturers, they'll say, basically, are you Jaguar? Are you somebody bigger than Jaguar like Apple? No, right, we'll go down to the back of the queue. And then at times, there's lead times of 56 weeks for one of the parts that we were using. So really, it's not just the manufacturer, it's the way the industry is. It's IoT which is driving it, because lots of things are being built and there just isn't the components around for it. So just something to be aware of.
Got him.
Sorry, I'm Richard Oliver from an independent electronics and software developer called Logicatronics. Within my supply chain, there is a company called ST Microelectronics. They've already told people like myself that we can expect 32 weeks lead time on components. And that is because when a corporation like Apple comes along with a new product build, they're building like 1 or 2 years in advance of releasing their product onto the commercial market. The next impact of that is, of course, if you're not a tier 1 customer, this reinforces the point here. So I think there's a little bit of learning needs to go on how the industry works. It's partly our fault because we're often reclusive designers and nobody knows who we are. So perhaps come talk to me afterwards.
Oh, thank you. How would I respond? We have actually found a company, not sadly in Yorkshire, that can offer the sort of, at least some of the sort of service I'm looking for. The sensors that we used, there was a British company, but its sensors routed all the data via its own servers before giving it back, which doesn't meet the needs for security or ethics. And frankly, if we're buying them, then we own the data. I'm not giving it away to anyone else. So we stepped over that opportunity and we found some from dear old Silicon Valley. Are they what we want? Well, they're pretty good, and they will do, and they can be delivered as required. They must have an immense warehouse of the things. And they have many good qualities. So I'm happy enough that we've got something for now. But it's not, I think, the way to go, because the ones I showed you in the picture there that look like sugar cubes, it's not necessarily the only technology to stick one under every desk. And I think my earlier comment was you can generate too much data. Do you need to have data that's so fine-grained? And the answer is yes in some places, but probably, well, certainly not as a whole. So if you're doing a multi-story office building, you could do one for every workstation, but you don't necessarily understand more because you've got a lot more data. You can actually understand less. And something that's good enough might be better. So a different type of sensor that's more coarse-grained in its approach is going to be sufficient. And if it isn't, then you can go in with the more expensive units and stick them on the desk and find out. But I think it should be iterative. But what we're trying to do is to drive the cost down as a service. This is other people's money. There's enough buildings out there for a market. But I mean, if you look outside here, all the buildings are dumb. And even the new ones, which are apparently smart, that capacity isn't being utilised. So the people in charge haven't got a clue. They really don't, and they're not interested, you see. Okay. So it's...
Any more questions?
Interesting.
No more questions. Fantastic. Right, I'm going to move the agenda around a little bit because we're talking about hardware. So, Richard, are you okay to do your talk now? Yes. And then we'll have Luca next, and then David after that, and then we're finished. So, we've got 3 talks left. Do people want to have a cup of tea and come back, or would they like to crack on? Keep talking. Straight through. Tea after so we've got 3 talks to go. So, how do you want to do this?
Whatever's easiest. If I'm on there, go from there if that's easy.
Did you post your...
I shared it with you, but I've got it on a USB.
Did you email it to me?
I emailed you to access to a Dropbox one. I've got a USB.
Right, let's do it this way. This works. Right, I'm alive. Right. Okay, over to Richard. Some people grabbed a cup of tea, haven't they? But yeah, we're starting. So if you want to join him, yeah, let's get you clicked on. So you put that in your back pocket. Very good. Oops.
Oh, let's go back a slide. Good afternoon, everyone. Oh, people running back. My name's Richard Holmes. I'm from a company called Arrow. And we're one of those strange organisations, so just to scene set a little bit. Oh, it's off and on its own again. It's playing. So we're one of those large organisations, bit of a global company. We've got one of our UK headquarters up the road in Harrogate, just like Chameleon. And we've been around since 1935, and we're a technology distributor. So basically, as I described to somebody earlier, just trying to describe what and how we think of us like a builder's merchant, but for tech. And because we've been around 80 plus years, we've seen a lot of changes, and we're a little bit more than a builder's merchant. We're a little bit more than just a warehouse and distribution. We work with people like IBM. We work with Microsoft, HP. We work with people at Analog Devices. We basically act as a function between people that are building products, software, hardware devices, and those vendors and suppliers, and we help with the supply chain, to put it bluntly. We've encountered a lot of change and growth over those 80 plus years, and we're a $26 billion business, I think, as of close of last year. So we're quite good at what we do, but what do we do, and why is it relevant today? So for us, our business sits in silos. So we have a global components business. So the sensors, the componentry, the connectivity that goes in the devices that people have been talking about today, we supply to those people that are building things. We have what we call an intelligent systems business. So for certain businesses, we build things. We work with fabricationless manufacturers in building the products that they design. And we also enable those. We turn them from dumb devices to smart devices. So as connectivity comes into those physical products, we work with suppliers and manufacturers that deliver that sort of stuff. We then get to my side of the business, where I sit, which is what we call enterprise computing. So that's basically any sort of technology that sits in a data center. What we invariably call cloud, whether it be hardware or software. When we talk about IoT and we talk about cloud, we work with businesses that build apps, build services, deliver solutions from data centers. And then to complete the cycle, we even have what we call a value recovery business. So yeah, we've got a lot of high technology kit with very expensive, very noxious products in them. An increasingly large part of our business over the recent years has been about ethically and environmentally disposal and recycling and repurposing of that kit. So that's kind of how we've grown our business over 80 plus years, but the Internet of Things has basically driven us to change. We as individual businesses within that Arrow group have to communicate and collaborate, and even though we touch pretty much a lot of elements of IoT, it doesn't mean that we can deliver turnkey solutions ourselves. That's what our downstream partners and the businesses that we work with do. And to be fair, it's what a lot of the manufacturers that we work with are increasingly coming to us and asking us to do, because they'll sit in one of these pods and they'll lack either skills, experience, relationships with businesses that can take ideas and take prototyping all the way through to a production and deliverable service or solution. But we've changed, and that's really what this 10 minutes is about how we've changed as a business. We're now a platform. I said we're more than just the sum of our parts. We're more than just a warehouse, very big very widespread warehouse. When we talk about platforms, invariably, people think about things like Uber, people think about, Facebook and all social media platforms. And, we could have left things by saying, right, all those vendors, all those suppliers, what we're going to do is we're just going to put our catalogs, we're going to put the ability to buy those things up on the web. There you go. There's a digital transformation story for you. Done that. But increasingly, the nature of the people that we work with is changing drastically as well. Not just established businesses that have got a scale, a customer set, a specific set of solutions that they take to market, and they're just looking for, we were talking about earlier, that speed and improving that level of service, that they want things here now, they want access to things like stock, inventory, that type of thing. But increasingly people want access to not just that information, they want access to things like reference designs, how-tos, articles, videos, not just the product data sheets in a dumb sense. And the platform for us has evolved out into even something that we call a design center. So online tools and the ability for developers to collaborate in an environment from our website to help customers and businesses and individuals design products that very much lend themselves to the sort of activities we see in IoT. And IoT becomes an increasingly important part of this platform, more so when we add on other services. So thinking about what we were going to talk about today, not really knowing the audience, but knowing that obviously IBM are working with the ODI and sponsoring last week and this week, it seemed appropriate that if we were talking about the change that Arrow are going through, we'll talk about the certification program. So somebody mentioned Kickstarter a few minutes ago. We've partnered with Indiegogo, another crowdfunding platform, to create something that we call the Arrow Certified program. And that's really because we have this platform, we know the types of customers and partners that we're working with are changing. How do we help? How do we engage with and basically how do we supply products and services to individuals, businesses that might not have a trading history, that might have a great idea but no firm set of commercial foundations or skills or are lacking some level of experience that, we've taken for granted over those last 80 years. So working with a crowdfunding platform, working with our own platform, and working with a couple of technology partners, of which IBM is one, what we aim to do is try and engage makers, developers, the project teams within established businesses, and support them in that journey from ideation through prototype, through scope of a production-ready and deployable product, and then also overlay that with the ability to potentially go to crowdfunding for a number of reasons, whether it be to test the market, to gather the collateral to actually take the next step forward. And really this has been something that we've been working on in the US for about 12 months. This year, Indiegogo and Arrow Digital, guys behind the platform, have decided that we want to bring this into Europe. So really, we're engaging with entrepreneurs. We're engaging with not just entrepreneurs as business owners, but as individuals. And how do we engage? Well, really any stage of product development. If all you've got is a great idea, or if you've got a prototype, or if you're looking at the next version of what you're doing, anybody can apply to the program. You don't look for purely businesses that have been around for less than 2 years or 12 months. We don't look for just a specific market segmentation. And what are the benefits? So we're a big global supplier of componentry and devices and products. You pass the application process, yes, there'll be a commercial discount, there'll be free shipping on products. Because IBM are a technology partner in this program, there'll be a a level of access to some of IBM's cloud services to help with if you're looking at taking on cognitive services or just an IoT platform to help control and manage your device. And also what we'll do is we'll plug into some of the global engineers that we have that will help with that rough prototype to production ready conversation that's needed. So mentioning about parts being in constraint. What happens when Apple or a big manufacturer drops an order at a global level? Or what happens if you've included a part or a component that isn't certified for the market that you need? But to get something ready quick and to prove the concept, you've gone for the prototype piece, the cheapest possible component. What happens if you've picked a component that is only going to be manufactured for the next 2-3 years, yet your product is going to have to be out in the market for 5, 10, 15? That's the sort of feedback that we look to be able to give. And obviously, what we'll do is we'll work with the suppliers that we work with to help align and find that right information and hopefully take that idea of a concept of, well, take that idea of a product or a solution from concept to prototype to full blown. So if you apply to the program, if you're successful in getting through, and if you actually achieve certification, what does that mean for Indiegogo, for you, for us? Well, extra promotion. Extra promotion in the fact that we produce a badge that sits alongside your product and your application on that crowdfunding site. Hopefully, because of the size, the scope, the scale of Arrow, that gives you and your product a little bit more oomph behind it. There's a little bit more, we say trust, but actually it's a known knowledge that you've gone through and it's been verified by somebody that has a connection with, on the component side of things and the sensor side of things, 900 plus suppliers. On the IT side of things, 120, 150 vendors that we work with. We also, and it's really important, not in every single application and every single achievement of certification, we have put our own cash down. So we contribute flash funding to the program as well. And also you get a discount off a level of the components and services, manufacturing support, and some of those feedback and wraparound services that we can put in. And if I go back a couple of years, that's so not what we did. So not what we did. We were a distributor, and at really boring dinner parties, and some people would come and go, "What do you do for a living?" It's complicated. We were always those people involved in the supply chain of products that you'd buy off a high street or that ITC shops would take into retailers or end clients. We were always those hidden types of businesses. And really, we're starting to see a shift. We were very much business to business. So, see the guys from Leeds ODI in here today. We'd always be working hand in hand with businesses that were producing something that was then be onward sold. It would ultimately end in a device that would probably be sold into public sector, private sector organisation. And we still do that. So Mark and my colleague Dave that are here today, we spend a lot of our time working with businesses that are developing IoT or smart solutions and services and taking to market. But increasingly, what we're starting to see, especially through this Indiegogo collaboration, is we're working with businesses like Anywhere. Anywhere are a Dutch company, I believe. No, Danish company who've produced a smart coupling that goes between a standard light bulb and a light socket. It's packed full, jam-packed full of sensors so that you can not just only control putting the lights on and off and set timings through the app, but it has a myriad of other sensors that you can layer on additional services for. And really, Anywhere aren't just looking to be a smart bulb manufacturer because they're abstracting themselves from that. Through sound sensors, they are looking at impacting home security and adding layered services on. Again, that's more consumer facing. We as Arrow, we'd probably be working behind the scenes in the past with Anywhere, but we certainly wouldn't be bringing them into a program like this, and it certainly wouldn't be something that we'd have the ability to engage with a company that was a relatively small startup. Big Clown. Big Clown are another European company based out of Prague, and they've created an IoT starter kit. There are two sides to their business. There's an IoT consultancy, and then there's Big Clown. And again, both have been through the ARROW certification program. Both have gained access to our technical resource. Both have received the certification mark, and I believe Anywhere recently received an element of flash funding from us. So really that, in a real quick run through, it's just a potted history of where we were, who we are, how we're changing, and how we're starting to see that IoT brings a whole raft of new challenges to a big organisation. I do us a massive disservice by putting us in four buckets and 4 streams. There are 18,500 employees globally, and we've always focused on doing one job really well. IoT demands a level of skills from engineering all the way through up and into the data center. And we have to consider things like GDPR and security and the level of service that's being provided and the user experience and the connectivity. And really through bringing together the groups of our business, hopefully we can guide, we can add advice, but it's very much about creating partnerships. And in a nutshell, that's pretty much me. So if you're interested in the certified program, websites, email address for inquiries are available, or please do try and grab me before the end of the day, and I'll make sure that Paul, you've got these slides, and we're learning daily. We are stepping out of our comfort zone with a lot of the conversations that we have. But there are people throughout our business. We've made a fairly significant investment, not just in the platform, but in people to focus on elements of IoT, and we're here to help. That's it.
So that's fantastic, and it just shows you how the world's moving so fast and how different a large organisation, ARROW, are changing to respond to it.
Yeah, from the conversations we first had a couple of years ago.
It's you're having to change because the world's changing. So, any questions for Richard? Does anyone want to join the programme yet?
Actually, I've already joined.
Have you?
So it was on the America, which was offered.
Yeah.
The US business, if you were to be eligible for the flat funding, that changed recently.
Yeah, it's just changed. Like I say, I think Anywhere have just, in fact, Anywhere have, because one of the slides I put up with the platform, they've received, I think it was 200k. 100k. And I know Big Clown, Hardware IO, let's actually give them their corporate name, they've applied. I don't think there's been a decision met on that yet. So it's actually, we've got people, there is a UK partner on. I don't know if they were through certification yet, and we know that European partners are now applying for the program, coming through certification, and in certain cases getting flash funding. So we're playing catch up with Indiegogo.
Interesting times.
Yes.
Good. Kerry's got a question.
Hi. Do you have criteria then for sort of gauging whether the startup is appropriate for the program?
I think what you'll find is there's so many different types of organisations that we deal with that there is a due diligence process, obviously, because to get the certification mark, we're committing sort of our brand behind it. So there'll be a rigorous process. There is a rigorous process behind it. Obviously, the speed that we go at, it could be a couple of weeks, a couple of months, and it could mean that. Because this is open to people that have got software and hardware element, your first point of engagement is probably going to be with some of our hardware engineers. If the proportion of the solution is probably more towards, say, software and cloud services, then it'll be passed through to relevant experts in other parts of the business. And that takes a few days to sort out. Most of what we run will be through access to engineers, primarily where we've been operating in the last 12 months in the US. But we're a global organisation. Sometimes that means pulling long days. So you'll get local support. And
do you advocate at all, I suppose new entrants or potential new entrants talking to people who've already got the certification?
Oh, absolutely. Okay. So last week we were at an event in London, and both Anywhere and Big Clown came along to basically talk to people that were interested. So we certainly push people like that forward to give you a view of the realistic experience and not just what it says on a PowerPoint.
Thank you very much.
Fantastic. Any more questions? Okay. So I think as Kerry was speaking, it'd be good. We'll have Luca from IoT Tribe. Both of you can come and talk. But let's give Richard a round of applause. And wouldn't it be amazing if we could get a Yorkshire-based or Leeds-based company in the programme? So I think we're going to try and make that. Stephen has got some things out of your sustainability lab that could go there, haven't you? So, yeah. Fantastic. Okay. Hey, no, not that one. We use the white one. Yeah. Let me plug you in. So, Richard, have you got the microphone? Okay. Let me see if you switched on. Is the green light on?
Yep. Should be in.
There we go. All good.
Let me see where I've put the. Yep.
He's taking it. If you could use the arrow, I'll just get it.
Yep. Should I just use the arrow? Yep.
Over to you. Away you go.
Yep. So, hello all, and thanks Paul for inviting us over here. I'm Luca. I'm an engineer by profession, but actually digital enthusiast, serial entrepreneur, and actually passionate about IoT, and more specific, smart mobility and smart city. Today I'm here with my colleague Kerry to introduce you with our experience at IoT Tribe. And let me ask you, how many of you have actually heard about the work that we've done over the last 3 months at IoT Tribe? Please raise your hand. 1, 2, 3, not many. So let me ask you, do you know what is an accelerator program? How many know what is an accelerator program? Please raise your hand. Okay, quite a few. So let me explain you what is IoT Tribe and what is an accelerator program. So IoT Tribe is born to be a 6-month acceleration program in Barnsley. In this program, we basically intake startups from all over the world, mainly focus on Internet of Things technology, directly or indirectly, so hardware-based, software-based, but all to do with IoT. They are early stage. That means that they've got some sort of market fit proof of evidence. So they've got most of the time they've got an early stage prototype. Some of them already run a crowdfunding campaign. Some of them are actually getting into their first batch of produced PCBs. As I mentioned, this acceleration program meant to take these startups and accelerate their market viability from an engineering point of view and from an investment point of view in 6 months. Why 12 plus 12 weeks? Because the first phase is very hands-on working, and the second phase is actually working on an investment brokerage style. We are based in Barnsley, and I'll tell you more about why we're based in Barnsley, but just in a few minutes. So, We started our first accelerator program this year, and it's been in January for 3 months. We just actually concluded the first phase. We've worked with only the best IoT startup in the world. So we have selected 9 IoT early stage startups. The application have basically come from all over the world. We've received Colombian, well, in general, South American, European, Asian, and of course, British application as well. At the end of this recruitment process, we've selected 9 startups. These startups, they mainly cover they cover a wide areas of wide distinct areas in the field of IoT. So we've got from smart building to smart farming to healthcare to to asset management to smart boating, and finally also machine learning and asset tracking. Let me mention a few of them. So Gartensweg is a smart home solution for your personal garden. So what Gartensweg realized that many young people, many families, especially living in large cities, they want to build, they want to grow their own food at home, their own vegetables. And so what they've started to do is they started to educate these people with a simple garden, which is a box, is a bamboo box that you receive at your home, and by the simply push of a button in your mobile phone, you can basically control the water, the lighting, and so on. It runs automatically based on basically lighting sensors and all other sort of temperature sensors and so on. But what it does is also allow you to basically control it from your mobile phone. Another startup that, as I mentioned, comes from Colombia, GreenyWave. They've conceived a mesh solution for smart metering. So they're basically empowering the South American market to control the waste of water. So with these, they can basically beat one of the largest problem in the basically the underdeveloped world. Someone was mentioning earlier on that they haven't seen the value on the water metering. Well, I would like actually to for that person to speak to them, because at the moment it is a problem in the underdeveloped country, but it's becoming a problem in our world as well. And then let me introduce you also to Proxy Group. Proxy Group is a Polish company which is basically making use of RFID for asset management. So we're talking of an intelligent warehouse that basically by the implementation of RFID can basically know where any item on the shop floor is basically moving. And so, for instance, not just having a right control in terms of the numbers of what is coming in and what is going out, but also visualizing in a immersed environment what is actually happening in your shop floor anywhere you are. Basically, just by putting a 3D glasses, you're able basically to understand what's happening in your warehouse in real time. So the type of work, as I mentioned, that we've done over the last 3 months with the startups is mainly engineering readiness. What does it mean? This means that us, together with experts in the field in IoT, basically worked on a daily basis, and when I say daily basis, literally 7 days a week, on basically fast-tracking these prototype to a later stage of maturation, basically, in order to prepare this company to make the enter into the crowdfunding campaign, but in general to be able to basically produce their first large batch of electronics. we can do that basically because we've got expertise in-house. We've got 2 software and hardware engineers that work with us full-time, but also by basically plugging in experts in different subject fields. So certification has been one of them, cybersecurity, and so on and so on. IP has been another one. But also a focus, a secondary, very important focus has been on business coaching and investment coaching. So from the first week, we've been stressing the fact that the startups need to be able to present their company in a very compelling way, in a manner where they can always basically sell their value to whether it is to a customer or to potential investors. And we've done that through basically partnering with an important company based in London called Capital Enterprise, which is an investment fund. But then, and from the business coaching side, we had a business coach full-time with us, which was meeting with the startups on a weekly basis, setting up their objectives and their roadmap towards the next 3 to 6 to 12 months vision. If that wasn't enough, we've provided the startups with opportunity to network, and you know how important it is, especially when you're doing business full-time. Okay, so we've organized 10 events over a period of 3 months. With more than 300 people turn out from literally from Barnsley to Leeds to Sheffield to Manchester. We basically covered the whole north, and if that wasn't enough, we've also run 2 very successful events in London, one at the Shard with more than 70 attendees, and another pitch day in London where the TechCrunch editor has actually been part of the presenter and speakers. Also, we've offered the opportunity to the startups to actually fly with us for 2 expeditions, one in Europe in Dublin and the second one in Asia, in Singapore. We've identified those locations primarily because Dublin has got a very strong manufacturing ecosystem, but also very, very digitalized as well. And on the other side, Singapore is basically that safe face of Asia. So it's where digital is happening, where you got the bridge to China, but with all the level of certification and all the basically assurance that you need for a successful IoT venture. And so let me introduce you to Kerry, our partnership manager. Kerry, can you introduce us a little bit on the work we've done from a partnership point of view?
2 minutes.
Yep, 2 minutes.
Thank you. So I'm Kerry Batchelder, and I work a lot in Barnsley at the Digital Media Centre. And I've just had the great privilege of working with IoT Tribe in a partnerships role. And I've been trying to help them engage with the local manufacturing ecosystem and other businesses to try and get some pilot studies going. So our main sponsor is Rolls-Royce, and we've managed to have 3 pilots with them. We're also engaging with some big utilities businesses. That's looking very promising. Local councils around connected healthcare and lone working. And then also with the manufacturing industry. For example, one of the businesses, Proxy Group, who does asset tracking in the virtual environment that Luca described, we're getting a pilot set up with a big manufacturing business in the Sheffield City region. So it's gone really, really well, and the companies are ambitious and they've got excellent products. So if anyone's interested in getting involved, please have a chat with me. We're planning another cohort from 2019. Luca, I'm ready for... So the next slide talks about why Barnsley. So Barnsley, as you know, is a town between 2 big cities. What's it got going for it, and why did IoT Tribe choose to site there? Well, what happened was there was a funding application with Innovate UK, and there was the option of running it in Manchester and Barnsley, and somehow Barnsley won out. And the reason for that is that back in beginning of 2017, we ran a program called Connected Manufacturing, with the whole intent was bringing the digital and manufacturing communities together. That was a big success. It's looking likely it's going to be a much bigger 3-year program in the city region. And as a result, we really sort of had the groundswell to run IoT Tribe. And also this building, the Digital Media Centre, run by my colleague Tracy Johnson, is a real hub in the whole of Yorkshire for the digital community and for engaging with other industries. So this really gave us the credibility and the opportunity to run IoT Tribe.
Yep. So, yeah, and if that was enough, we've basically, we're a tribe and we're constantly looking for collaboration, okay? So, thanks to the DMC, we've opened up into a space that we didn't expect at the beginning. So we had actually the enthusiasm of local people that wanted to basically support these very interesting projects, and so the way we've been received into these manufacturing ecosystem has been just amazing. So we're delighted to be based in Barnsley, and we are constantly looking for potential for collaboration. And as we are constantly looking for opportunities to collaborate, we're also looking for enlarging our network. So our network comes from basically 9 years of experience running these type of program all over Europe. So we've been in Dublin, we've been in the Nordic country, we've been in Spain, and this year we've basically started our journey in Barnsley. As Kerry mentioned, partnership with Innovate UK, Rolls-Royce, and I'm opening up to more stronger and interesting partnerships. So we're really open to listen anything you've got to basically to offer, to put in the plate, and what type of support you can give to these very early stage and interesting concepts. So let me thank you for your attention. Just as a reminder, next year, January, March, there will be another cohort. So if you're an entrepreneur, please join us on the website, or just write an email or come and talk to us. If you are thinking of collaborating with us in any way, please come and talk to us.
Fantastic. So, any questions? No questions.
Easy.
Good,
So
that was an easy one. So we're down to the last talk. It's okay, thanks,
Thank you,
Kerry.
Paul.
So David from Vicardio. Get my machine up. So yeah, if you just, is that working?
Are they? Is it working? Yeah.
Yes, we're working. I'll turn this one off.
Are you using this one?
No.
No?
I'm using. Could you pass me that white cable? Perfect. So if you introduce yourself, I'll find your slides.
Yeah. I really know what the graveyard shift is now. So my name's David Pearce. I'm with a company called Vicardio, and we're sort of moving the debate and discussion on to sensors, of which Brian wants to have much better sensors. So my company is bringing a sensor to market in healthcare. The healthcare market is sort of has a number of sensors which, in our opinion, have sort of been taken to the limit. We've got the heart rate on the Garmins and the Apple Watches, which you know, heart rate variability and everything. They're really being stretched well beyond the limits, and they're not that accurate. And then we've got the sort of sleep sensors, which again are being used extensively now in conjunction with the heart rate sensors. And so I become involved with a business who produced a sensor in the blood pressure monitoring arena. But actually this sensor goes a long way beyond blood pressure, which I'll come to shortly, and I'm sure there may be people in this room, whether it be buildings or other things, who will see applications. Hypertension is the world's biggest health problem. In the UK, a third of people suffer from hypertension. A third of adults who've got a hypertension don't know they have the disease, and a third of people with the disease can't keep it under control. In fact, those figures have changed since November in America, where they have changed, the American Cardiology Association have actually changed and downgraded the American guidelines. So you can now actually be hypertensive with a diastolic blood pressure of less than 90 in America. So 48% of Americans are now hypertensive, and with the obesity, the diabetes crisis, that number is growing year on year. So this is a huge, huge problem. We monitor blood pressure. It is probably the most important physiological marker of human health. We've got height, we've got weight, we've got pulse, we've got temperature, but actually there's very few interactions, whether it be in chronic healthcare conditions, acute healthcare conditions, just going to any old outpatient's clinic or having an operation or critical care where a doctor or a nurse or somebody is not going to want to monitor your blood pressure. So it is a fundamentally probably the most important physiological marker of human health. Looking at IoT and all these sexy things, and again, rather like Brian's presentation, it's quite interesting sometimes to go back in time. A guy called Stephen Hales was the first person to measure blood pressure. He wasn't a doctor, he was a vicar who went to Cambridge, and actually there's a huge amount of historical medical talent and medical discoveries that were made by non-doctors, and he decided to measure blood pressure by putting a catheter into the artery of a horse in its neck, and actually recorded measuring the variation. So this was the first ever blood pressure sensor. It took another 100 odd years for Korotkov, von Recklinghausen, Riva-Rocchi to actually create the oscillometric methods by which we now currently measure blood pressure, and that is that you occlude the artery, and as the blood, and then so that cuff which blows up around your arm stops blood flow in the brachial artery, and as it releases, you get an oscillation as the blood starts to flow back through the artery, and then actually as you get down to the lower pressure, the diastolic pressure, that oscillation disappears. And that actually has been the fundamental way blood pressure has been measured for well over 100 years now. It really hasn't changed. We've put batteries in it, we've put a digital readout on it, but it's actually not changed. So we currently measure blood pressure using those methods. There are huge problems with blood pressure measure as a current sensor. Most people who've had their blood pressure in this room will know that actually the cuff is very unpleasant, and that in itself causes up to 30% of the population actually have white coat hypertension, caused by two things. One, being actually at your doctor's, and secondly, by this great big thing blowing up around your arm, which releases a load of adrenaline, and guess what? By the time it starts to measure, it's changed your blood pressure. And that's a huge problem. You can't be treated in this country now for hypertension unless you have a 24-hour ABPM study, which measures your blood pressure. It's got to be 17 times in a 24-hour period. Has anybody in this room had an ABPM study, can I ask? It's quite unpleasant, and actually, when you get woken up at 3 o'clock in the morning by a cuff squeezing your arm and your adrenals go into overdrive, the question is it really measuring your blood pressure at night? So again, the accuracy even of those is questionable. Blood pressure machines and oscillometric machines need frequent calibration. Over 50 million devices are sold to the public every year worldwide, and I would doubt less than 10% will ever get recalibrated, and most GPs will actually get their machines recalibrated at least twice a year. So it's one of these devices people buy, they stick it in a cupboard, but within 6 months it's actually useless. So there's various tech which is emerging in oscillometry, and the big companies such as Omron have been looking at getting it onto the wrist and then creating a wrist-based watch. We find it interesting. The top three pictures are Omron's CES efforts for the last 3 years, 16, 17 and 18, trying to actually create a cuff around the wrist. They never seem to go anywhere apart from the week of CS, and then they seem to sort of disappear. And by September each year, it sort of turns into sort of a load of hate, sort of hate forums saying when is this product coming, and it's probably not coming, and then it gets re-released. There are some finger-based devices And actually I saw one a couple of weeks ago on The Verge, I think, where somebody's actually using a light on a mobile phone, and actually the review actually slated it, although it was, saying, it's very excited about it, but basically you're actually occluding the blood flow in a capillary by pushing it against the light, and as you release it, you're actually sort of administering self-oscillometry in the tip of your finger. But again, none of these devices have ever got through any CE marking or FDA approval. The next technology, which again Apple, Garmin, and everyone are flogging to death in sensors, is the green light on the back of your Apple Watch or your Garmin, which is essentially PPG technology. So you're firing light a couple of millimeters into capillaries, and you're measuring differences in that. Again, this was the array we brought back from CES to the lab to test. $20, $30 Chinese products. We thought this bottle of Yorkshire Water's got a blood pressure of 130/89, so again, it's not a very good start. I got involved in a company a year ago who are really an amazing couple, a doctor and his wife from Welling, who have been working for 12 years on a blood pressure sensor in a totally different direction. And what they've achieved, I think, is absolutely remarkable. This is a micromotion sensor, and that's why I say this has probably got lots of markets well beyond health. It's essentially a button which sits on top of a flexible silicon optical fiber with an LED. Hopefully we can get enough to manufacture an LED at one side and a light receiver at the other, and it moves in two planes. So it moves on a spring both up and down, and it moves side to side. So actually, from the change in the light path, from the micromotion of the radial artery, they can measure all four vectors of pressure and flow. So they can actually measure direct beat-to-beat blood pressure with no compression at all, and no requirement for any biological calibration, which is really a total revolution in terms of healthcare. So imagine, say, an anaesthetist. An anaesthetist's job is to put you to sleep, keep you pain-free, and keep your circulation going while whatever the surgeon is doing gets done. And most people know it's the most dangerous part of any operation. An anaesthetist currently uses a cuff in 99.9% of patients and blows it up every couple of minutes. The intra-arterial lines, which are sort of saved for people who are going to ICU after a theatre, so maybe somebody with a coronary artery bypass will get an intra-arterial radial line. This device actually measures blood pressure and displays blood pressure, we believe, as well as an intra-arterial line. I'll come back to that in a minute. But in terms of sort of IoT, and we're looking at making these devices both as a desktop product with a SIM card and IoT in it, and also as a wearable with an app. So this is the latest prototype of the wearable device. And again, it will be, and it is a medical grade sensor. It's not going to be marketed without CE marking and FDA approval. But the really interesting thing comes in terms of that big data aspect, in terms of what don't we know about blood pressure. What do we know about the real effect of not having your blood pressure measured with a cuff, and maybe having your blood pressure measured over a week on 17 times a day without you knowing about it? How does that experience, that anxiety change? And how does that level of granularity affect the people we do and don't treat for blood pressure? Looking at the beat-to-beat variation, there's a lot of people who believe that blood pressure isn't a single reading, and that, I mean, if you think about the flow and pressure through a tube, it may well be people have a blood pressure of 130/95, and that's quite constant. And actually, if you think of it in terms of just a plumbing pipe, a constantly slightly high pressure through a tube, which we might treat today, might be a lot less dangerous than a lower normal pressure, but with a great deal of beat-to-beat variation in it. That may be much more damaging. But because we've never been able to measure beat-to-beat variation in health, apart from in people with invasive lines in who can't get on the street, we don't have that data. So we're very excited about looking and starting to explore, as we bring this product to market, the concept of having, 100,000 people who are measuring their blood pressure 5-6 times a month for sort of whole day periods, and then starting to see what variations we see and what events we can see looking at big data and machine learning in terms of, some of that population will go on to have strokes, some of them will go on to have heart attacks, and there may well be a lot within the big data of predictive outcomes where we can actually say, do you know what, if your blood pressure goes up for this long on a particular day, then go and lie down, because in the next 24 hours you're 10 times more likely to have a stroke or a heart attack. So that element of big data and an increased granularity of this measurement and an accurate one. And so I'll think I've got a video here if I can listen to me technically. Should be a video. Huh. Nope. It says. Playing? I just opened the. Yeah, it was embedded in there, but it might not.
So is that the end of the presentation?
Yeah, that should have the video in it. It was an embedded one, but it might not have come through.
Okay.
No, it's just an embedded video. I can show people. I mean, essentially all the video is showing is the device, and it's actually, have we got? Did I see an iPhone?
Yeah, let's try it.
No, is that USB-C? No, it's not. It's a Lightning. I thought I saw an iPhone. No, don't worry. Well, I can show anybody who's interested, and it's on our website. But essentially, what you see in here is a full arteriogram. So you're actually seeing the peaks and troughs of blood pressure, and you can even actually see what we call the dichrotic notch, which is when as the pressure is coming down, your aortic valve closes, you get a reduction in backflow, which actually you can see a slight up pressure on the curve. So yeah, this is an example of a new sensor, and a new sensor which will be medical grade and which we are looking to bring to market. We're currently in clinical trial in Barts, where we're actually comparing this to arterial lines, and when that's finished, the CE marking process should hopefully be complete in 3 to 4 months, with product being manufactured and sold to clinicians and consumers in Q4 this year. And from there, we'll hopefully start to look at the data and how that may influence and change healthcare. Thanks for listening.
Okay, so we made it. And I think we should give David another round of applause because he did the very last talk. We're going to try and we managed to get a load of talks. We've got some really fantastic discussions, and it was done quite with little notice. I'm not going to say in a rush, but we did it with relatively little notice. But it just shows you how much is going on in this part of the world, what interesting things are happening, and it shows us what might happen in the future, I think, with a little bit where things are going to happen soon. So we've got a couple of things. If you've spoken today, please share your slides or whatever, however you want to do that with us. We're going to put a page up afterwards to share them with anyone who might be interested. If you would like to get more involved in things Bradford and Leeds, or things Leeds and Bradford, depends how it is, we've already had some people volunteering. If you just, we'll give you a pen, if you can write your name on there, and we'll contact you afterwards and share some more information about that. I've got a... please just use the whiteboard markers, not anything else. Don't use Sharpies. And I think we should give ourselves a round of applause because it's been a fantastic day, and thank Lucy Zodi and AQL for sponsoring us. That's it. If you want to stick around for a cup of tea and a coffee, catch up with people, you'd be most welcome. We didn't